Hello, Java programmers. Today we continue our discussion of object-oriented programming. We will introduce more concepts and apply them in programs. We will discuss constructors, including the default constructor and the copy constructor. We will discuss passing things to methods. While that's not strictly object-oriented, it's still important. We will discuss private, protected, and public in a little bit of detail, but not too much. And we will continue adding validation to our setter methods. So grab your Eclipse IDE, start it up, and let's get ready to roll. The first thing I'm going to do is create a project. As always, it's a Java project. So I can just search for the word Java in the filter, or I can just keep opening Windows until I find it. But in the new project dialog, I want a project made of Java. And this project will be called Super Bowl Ticket. We are going to model a ticket to the Super Bowl. And I'm pretty sure, I haven't checked recently, but I'm pretty sure that the Dolphins are not in the Super Bowl this year. I don't use the module info. I'll just hit don't create. If you create one, that's fine. I recently reinstalled Eclipse to get the most modern version, and it's now asking me if I want a particular perspective, and also because I created a new workspace from that new version of Eclipse. Now I'm going to say no because I like my perspective the way I had my perspective. If I say yes, it opens several windows that I know I'm not going to use. This is completely up to you. The way our IDEs lay out, or the way our desktop looks, is personal preference. This is the way my desktop looks to start out. There's actually too many things open here as it is. I don't need anything except the console, the Project Explorer, and what will become the Edit tab for all of my code modules. Remember, if I lose the Console tab, I can go to Window and go to Show View, select Console. If I don't see Console in the View menu, I can go to Other and search for that window. That's what I usually, in a more complex application, I might have the database connection window open. I'll certainly have debug windows open. We'll get to those. And I might have some other build tools open. But we're not doing complex projects at this point, and I like to have a nice, clean look on my screen. I'm working from a 15-inch laptop, so I don't have a lot of real estate. It makes me happy just to see as little as possible right now. So in our project, we're going to create a couple of classes. And if you remember back to last time, we created an avocado package. And we had two classes in that package. We had the avocado class, which modeled an avocado. We had the main class, which is our entry point for the project. And we will start out a similar way here. In the source folder, whoops, I don't know what I just did. Sorry. In the source folder, new class. I'll create the main first. That's a good thing to do. I'll call the package Super Bowl Ticket. It's a pretty good description of what we're doing. I'll add the public static void main to the main class. Eclipse writes a little code for me, opens it in an Edit tab. I immediately delete this to do because it drives me nuts. I don't like to be told what to do. At the very top, remember you have important things to do here. So add your documentation. Do not wait until the last minute. Do not wait until you're finished coding and you're ready to turn it in. Do that first. It gets you focused. And you also tend to forget if you wait till the end. That's not the professional way to do documentation. Okay, not much else to go in there right now. Notice that the package statement was added. In the same package, I'm going to put another class, and that's the thing that we're modeling, Super Bowl Ticket, capital S. Don't need a main. I already have a main. It's in the other class, the main class. Can't have two mains at this point. It would just create tremendous confusion for us. Click Finish. I have another immediate task to do. Add documentation to that module. Every module that you create should be documented with that comment header at the top. We've talked about all the things that go in there. That is not optional, and you will lose points if you don't do it. Okay, we don't have any design to work from. You know that from all the harping I've done on this, somebody will hand you a design spec, or you will come up with one to create classes of any significance. We're not doing that in this class because this is not a design class. Therefore, we're just going to do this out of our head in order to illustrate concepts. Do not get the impression then that in a professional environment we immediately dive to our keyboard and begin typing in code. There's plenty of work to be done before that can happen. All right, let's say that a Super Bowl ticket has some private properties. By default, if you're not sure, properties are private. And then we provide getters and setters for those properties. Private, it has a row, it has a section. Uh-oh, my phone is ringing, excuse me. Sorry about that. A Super Bowl ticket has row, section, and seat. And that uniquely defines one specific seat in the stadium. You go to a section, you find your row, and then inside that row, you find your seat. And we need a data type for this. Let's say, for the sake of this discussion, that they are all integers. That makes it easy. Sections are numbered, rows are numbered, individual seats are numbered in that row. And if I know all three of those things, I can uniquely identify that seat. Let's also say that this class, this model for the ticket, has some kind of unique global identifier for each seat. And it can't be guessed. You don't know what it is based on the row, section, and seat numbers, but it's embedded in or attached to each individual seat. We want some unique gobbledygook, unguessable string of characters that will do that. That's going to be an added security level for each seat. It might be printed with a QR code on the ticket, or it might be transmitted separately from the ticket to prevent duplication. And we need some kind of data type to do that. And now we're branching away from what we've always done, is using floats and doubles and strings. We all have a good understanding of the basic data types. And we could make up some logic to create a random string and call that our unique identifier. That's a lot of work, and randomness is studied by mathematicians. It's not the easiest thing in the world to achieve true randomness. And we're pretty sure that there's probably something built into Java to generate this random identifier. If you don't know what it's called, if you don't know the generic term from it, you might have a little bit of a headache trying to find it. If you're given a design spec that says create a unique, random, unguessable identifier for each seat in the Super Bowl game, you might have a hard time doing that. But since I can help you a little bit, there's a generic term called GUID, Globally Unique Identifier. And if we search for that, there's all kinds of resources to generate globally unique identifiers. And according to this screen, I just used Google to search for GUID. There's an image there on my screen that it a little bit kind of sort of looks like the activation key for a piece of Microsoft software. Not exactly, but somewhat similar. It's got dashes in it. It's got groups of 4 letters and numbers. And the first hit that's provided here is a definition of it from PC Magazine, which is an old, not to say old is bad, a well-established, well-read magazine about personal computers. Gosh, it's been around for 30 or 40 years. And then below that is a free online GUID generator. The website is actually guidgenerator.com. That's pretty neat. And we can click a button and it generates a global identifier for us. And we could do that, but if we're going to generate GUIDs for 60,000 seats in SoFi Stadium, where the Super Bowl is being played and the Dolphins are not in attendance, then we really don't want to have to click on this button 60,000 times and manually transfer 60,000 GUIDs. And I can't stand it anymore. I need to look and see how big this stadium is. Super Bowl, SoFi. I think it's SoFi Stadium, right? Yeah. And it holds 70,240. Okay, interesting. 70,240 seats. However, getting back to our GUID again, we found a website that will generate them for us. However, this is not a convenient solution by any means because we need 70,000 of them. However, if we modify our search and we add the keyword Java to the search, I get 6,360,000 results. I always get a kick out of that number. It's so big anymore. But the first hit we get is create a GUID in Java, and it's a Stack Overflow reference. We like Stack Overflow. We know how to navigate it. We're comfortable with it. The question that it takes us to is, what are some of the best ways to generate a GUID in Java? It's got 412 upvotes. That's really good. It's got an answer with 464 upvotes. That's very good. And it's one line of code. So this person provided one line of code to generate a globally unique identifier. And then they go into some discussion about the theory behind it. Can it repeat, blah, blah, blah. Yeah, sure, it can repeat, but the odds of it repeating are extremely, extremely low. The odds are low enough to the point where we simply don't care about it. I mean, if 2 seats end up with the same GUID, it's a tremendously almost impossible situation for that to happen. Looking at this answer in Stack Overflow, the answer isn't that great because it doesn't tell us how to use it. It's a one-line answer. It's been there since 2010. It's 22 years old. And I'm pretty sure that these days this answer would be voted closed or flagged as incomplete. It just doesn't provide enough help. But it's a good starting point for us. We can take that and Google that to learn more about it and find all kinds of Java references explaining what it is. Or let's just try something else since we're adventurous and we like to experiment. Let's just grab this line of code right out of this Stack Overflow page. And I'm going to go back to my project. And in the main, I'm going to paste in that one single little code snippet from Stack Overflow. It looks like a method call because it's got parentheses at the end followed by that semicolon. That syntax looks fairly familiar. The rest of this stuff, UUID is the class name, and then java.util are package names. And it looks pretty good, and it doesn't have any squiggles underneath it. Apparently, whatever it is, it's okay. It's syntactically correct. I don't see it generating any output. I could run this right now. Let's see if it even builds and runs. Okay, it ran. So whatever we pasted in is syntactically correct, but it doesn't generate anything to the console. What if I put something in front of it to catch what it sends back to me? Maybe this method generates a UUID and then returns it to me. Okay, and I'm going to get an error because it doesn't know what X is. But now I have a problem because I don't know what X should be. I mean, X is going to accept whatever this thing returns to me, whatever random UUID sends back. I don't know what that is. Is it a string? Is it some weird thing I've never heard of? Well, if I hover over it, will it tell me anything? Look at that. There's the Javadocs for the random UUID method. And keep in mind, we know very little about this method at this point. We're just trying to figure out how to use it. And once we figure out how to use it, we're probably going to stop studying it. And we're not going to dig into the source code or spend an hour researching it. We'll figure out what we need to get out of it, and we'll move on. Now, according to Javadocs, this thing returns a UUID. There's a new class we haven't heard of. What in the world's a UUID? Whatever a UUID is, this method and this class are built into Java because I didn't get any errors when I tried to use it. That means Eclipse and Java know what it is, and that's pretty cool. But I have to declare X. So all I have to do is follow the Javadocs and make X the same data type as what is returned by that method. The text of that description says it returns a randomly generated UUID. That sounds fantastic. That is exactly what I want to randomize the identifiers on all these 70,000 tickets. Makes me very happy. And when I put UUID in front of X, now I got a problem because it doesn't know what a UUID is. But it knows where it can find what a UUID is, and that's by adding this import statement, java.util. But look what else I could do. I could do the same thing on the left side that I did on the right side. java.util.uuid. Look at that, the error went away. I no longer have an error because both sides I fully qualified that data type. UUID is my data type, just like int or float or string or boolean. And it's not built into the language, but it is built into Java as a class that Java recognizes as long as I include java.util. Now that's awkward. You don't have to write out all that code if you don't want to. Let's take away that wonderful fully qualified name, and then let's let Eclipse fix it. Eclipse says, hey, I know where to find a UUID, And watch what it does. It adds an import statement up here. All the errors go away. And now line 11 looks pretty normal. We're declare a variable x that is of type UUID. That's what we're doing. There's a new data type for you to put into your arsenal. You know all about integers and strings and arrays and array lists and doubles and floats and booleans. Now you know about UUIDs. Don't know much about it. Can I print it out? System.out.println x. X is a terrible variable name. I'm just writing some scratch code here that I'm not going to need very long. Therefore, I just called it x. Can I print that? What do I get? There it is. I got a random looking string. Let's print a couple more. Let's see if it really does. Let's print 4 more or 3 more for a total of 4. What does it look like now? There they are. Now I have a problem. Look closely at those 4 random UUIDs. They are all the same. So every time I called random UUID, it sent me the same global unique identifier. So that's not very unique, is it? And I'm thankful now that I didn't stop after 1. I'm thankful that I printed out at least 2, and I can see that they are not unique to each other. They're all the same. Now, is random UUID broken? Is this method broken and it's accidentally sending me the same global unique identifier 4 times? Has the math broken? Is there something wrong with the universe? Probably not. It's probably me. I'm probably not using it the way I want it to work. So I'm going to go back to my search engine again. And remember, I said that this wasn't a very good answer, and the reason it's not a very good answer is because it doesn't go into any detail about how to use it to get any value out of it. I mean, this person who posted the question says what are the best ways to create a GUID, and it's pretty safe to think that they want more than 1. We have to figure out then how to make this work. So let's just Google the whole thing. I googled java.util.uuid.randomuuid open close paren. I googled the whole thing, even the semicolon. I just threw it all into the search engine. The first hit, as you might expect, is authoritative documentation from Oracle, the owner of Java. Let's take a look at that. And this might be overwhelming because it goes into the math a little bit, but let's try to figure out from here how to get unique values. And I'm just going to search for the word unique. And there's 4 of them. The first one is right there in the description of the class. Remember, UUID is a class. The second one is something about getting more information. That looks overwhelming. The next one says something about temporal uniqueness in a time base. That sounds like Star Trek. That doesn't help me. And then the last one is along those same lines. So none of the instances of the word unique are very helpful. I can scroll down through this, and maybe if I cross my fingers and squint real hard, I can find the usage of this thing that I need. But let's say for the sake of argument that we don't see it. This is kind of scary. There's a lot of math and a lot of terms we don't recognize. So let's go back to our search and let's qualify it and say example. There you go. There's a word we like. Let's look for an example of how to use this thing. Our search phrase now is java.util.randomuuid open close paren and then example. The first hit is another Stack Overflow question. Let's try it. This person says, I'd like to generate unique sequences of bytes. And this one says uuid.randomuuid.toString. And I look at this, and it looks exactly like my code. So now I'm starting to wonder if I should become an Amish farmer because I'm just not understanding what's going on here. If I look at that highlighted code on the screen, that's the same thing I'm doing. I'm calling uuid.randomuuid and I'm assigning it to a variable. In this case, they're assigning it to a string because they're also calling the toString method here. And I go back and look at my code again, and suddenly it hits me. Oh my goodness, I just printed the same thing 4 times. I only called the method once. There's my mistake. It's my user error. It's not a problem with UUID. I'm going to go ahead and replace my X in 3 of these print statements with the call to UUID. Okay? After a little bit of research and careful comparison and thought, then I figured out what I was doing wrong. Let's run that, and hopefully I get, there it is, I get 4 different UUIDs. Also notice that every time I run this program, I get 4 more of these little puppies. So I will never get the same ones ever again. And if you sit down and take the time to figure it out, the chances of these duplicating are just astronomical. It's probably the number of letters in the alphabet times 2 plus the number of digits, which are 10, and then raise that to the power of however long this is. Looks like it's about 20 characters. So it's about probably 50 to the 20th power. Just an astronomically large number, and the chances of duplication are infinitesimal to the point where we don't worry about it. But once I figured out what I was doing wrong, I now have a technique very easy for generating these random, unique global identifiers. Go back to the Super Bowl ticket again, and let's make a private UUID, and we'll call it just ID. How about that? Now there's a private property of that class called ID that is of type UUID. You can see this squiggle on my screen. I have the same problem I did in the main, that it doesn't know what UUID is, but it will import the java.util package to solve that problem. There it is. I have now a minimal amount of information to model a seat. I know where it is in the stadium, and I have a unique identifier for it. And I don't care. Keep in mind, sometimes we just have to let go. I don't care how the UUID is created. I don't care how it's represented. It might be a string. It might be some other magic sequence of characters. It doesn't matter to me. All I know is that I have it, and I can use it for my purposes. I don't have to study it for 6 hours to be able to put it into my program. Sometimes I will, and sometimes I won't. Good. So we have our data. Now we need probably, in most cases, to consider constructors. The question that we ask ourselves, and this would happen during the design process, is how will other developers, which I also refer to as customers, use our class? Okay? What do they need to do? So there's somebody out there who's going to create 70,240 of our objects. They need that many of the tickets, and probably more. that person probably needs a constructor because we need to do some of the work for them that's going to happen behind the scenes. And then I will show you what I'm talking about here. So let's put a constructor in, public super bowl ticket, open close paren. This is what will be called implicitly behind the scenes whenever we instantiate an object of this type. And we'll do that in a second back in the main. Now, whenever we create a Super Bowl ticket, it's going to have an ID. That's, by definition, that's a customer requirement. Every ticket has an ID. Therefore, it's not reasonable to expect the other developers, or the customers, so to speak, of this class to take care of that. We know it needs to be there. We should take care of it. A good place to put it is in the constructor. We can say this code runs every time an object of this type is instantiated. Therefore, we know that whatever we put in here is going to run. No questions asked. And that's easy enough. So ID equals, what's the syntax for creating it? UUID random UUID method. There you go. This is a bulletproof way of ensuring that all of our tickets will have that ID, no matter what. And then we could put a constructor in here, a Javadocs in the constructor, sorry. So set up a new Super Bowl ticket. And we could put here, if we like, it would probably be helpful for other developers. The GUID will be defined here. Whoops, spelled defined wrong. Okay. And that's just a courtesy. Other developers will read the Javadocs and say, oh, that's where that happens. Okay, that's interesting. Now let's go back to our main. And I don't need all of this anymore. I usually don't like to delete code. I think in this case, though, I will probably never care to look at this again because it's become so obvious to me now that it'd just be boring to scan through it. I'll delete all of that little scratch code that we wrote, and I will create a ticket. My ticket equal, whoops, sorry, got ahead of myself. Super Bowl ticket. I've been doing too much Python, and I don't have to declare the variable data types. Super Bowl ticket, my ticket, and that's my declaration. Remember, we have to do this in 2 steps. We declare, and the second step we instantiate. My ticket equals Super Bowl ticket. Open close paren. This instantiates. And that also invokes the constructor. That's where the constructor gets called. But Eclipse still isn't happy. It's so hard to make Eclipse happy. It doesn't know what that constructor is, which is kind of weird because if I look over here, there it is. There's my constructor. However, what we haven't done is save it yet. You can see the little star in the tab of that edit window. So the creation of Super Bowl ticket has not been saved to the disk, and therefore main doesn't know about it. Let's try saving everything and hope this error goes away. Please go away. Did I spell it wrong or something? Public Super Bowl ticket. Well, that's weird. All right. Again, too much Python. I forgot my new keyword. Too much Python. I have to start thinking data types again. The instantiation is triggered by the new keyword. And then the parentheses are a visual cue that we're calling the constructor. How do we know it's a constructor? Well, if you look over at the Super Bowl ticket class, the constructor has the same name as the class. That's your definition. Notice that a constructor does not have a return type. The constructor in line 16, there's no void or int or anything like that. You can't return something from a constructor, and you can't not return something from a constructor. If I put a return statement in here, it'll give me an error message. Void methods cannot return a value, which is extremely misleading because the constructor does not have the word void attached to it like other methods do, but it is implicitly void. Okay. Should this constructor do anything else? Is there any other functionality that is required of every Super Bowl ticket? No matter what happens, anytime we create a Super Bowl ticket, are there things that we always have to do? And we've agreed that every ticket has a GUID, but there may be other things too that will come apparent later. Hopefully in the design spec that you were given, you'll be able to ascertain what those things are. Now in the main, make sure I save it. In the main, we're good. We have a warning because we're not doing anything with the my ticket object yet. That's okay. We'll get to that. We have another warning that we're no longer using that import statement because we're no longer declaring things of type UUID. We can have Java or Eclipse remove that import if you like, or you can leave it in there and look at the warning message forever. That's up to you. All right. We can't do much more. We haven't provided any other functionality. If you go back over to the Super Bowl ticket class again, Eclipse wants to really do you a favor. It wants to reach out and help you. If you create a private class member, as we have here, we created row, section, and seat. Eclipse looks at your code and notices that you have not done anything with those private class members except declare them. And Eclipse is sad. Eclipse wants you to make use of the things that you declare. You haven't done that. Now there are two reasons that that's probably okay. One is that you just haven't got to it yet. And the other is somebody else is going to come in and do it later. But let's say for the sake of argument now that you realize, hey, I need to write getters and setters for all three of these things. Because remember the last time we talked, I said whenever you create a private property, you're almost always going to create a getter and a setter. You should at least consider that for every private property that you create. And Eclipse says, I can help, and it's jumping up and down and waving its hand. If you hover over one of those private variables, it offers to create you a getter and a setter. And that's a nice little fix because it's less typing for you. It also uses a very nice convention where it just prefixes the word get or the word set in front of the property name and writes you two methods. There's my getter and there's my setter. Bada bing. And then the error goes away. I'm sorry, the warning under seat. Now let's do the same thing for section. I did seat, now I'll do section. Got to go through it again. Do it one more time for row. I have now written, quote unquote, 6 different methods, 1, 2, 3, 4, 5, 6, the getters and the setters for those 3 private variables. Now I have given users of my class the capability of reading and writing the row, seat, and section. Okay? But Eclipse still isn't satisfied because it's also warning you that you have not done anything with the ID property that you created. And that's kind of true. All you did was assign it a value in line 18 of the constructor. You assigned a value to that ID, but then you didn't do anything with it. You filled up the bucket, but you didn't dump the bucket back out again. You didn't scoop out the bucket. You didn't share the bucket with anyone else. So the bucket ID is full. It's initialized, but I mean, it's like carrying around a bucket of water and never drinking out of it or giving it to anyone. Why would you do that? Okay, Eclipse wants to solve the problem for you the same way. Eclipse says, hey, you haven't used the ID field. I can create a getter and a setter for you. Please, please let me do that. Please let me do that. But at this point, you realize that you shouldn't let anybody else change the value of this GUID. Once it's been established, it's going to stay that way forever. And you don't want people changing it midway through their software or assigning it a new value by mistake. So you really don't need a setter. This is one of those cases where a getter is a good idea. People will certainly want to read that value from your object, but they will not be able to set it. Therefore, you just click Create Getter and Setter, and you unselect the setter. Click OK. Scroll down to the bottom, and there it is. There's your getter. That property has read privileges. It does not have write privileges outside of this class. These are design decisions that we make before we start coding, right? Someone has decided, or we have decided in our design phase, this is how this object should behave. You don't do this out of your head because you're going to get it wrong. The next thing you'll need to do is add Javadoc comments to all of your public methods. We've already written beyond the constructor 7 public methods. We have 2 each for row, section, and seat, and we have 1 getter for the ID. And I'm not going to do all of them. I'll do a couple just to illustrate. You don't need to watch me type all these. Get the seat number of the ticket, and then return number. It looks a little bit redundant, especially in this context of the entire class, but remember, these are going to be read by people who are using your Super Bowl ticket class, and they will never see this code. All they will see is the getter and setter Javadocs. Therefore, what you can tell them in a very short, brief, informative couple of lines will be immensely helpful to them. If you don't Javadoc these things, eventually you're going to find people who are hunting you down and saying, how does your method work? Because you didn't document it for us. Or, even worse than that, they'll just write their own methods and bypass yours because they don't know how yours work. And that will make you sad. So I did the getter for the seat number. I'll do the setter for the seat number. Remember, it's just slash star star forward slash star star. Press enter. It builds the Javadoc template for you. All you need to do is fill it in. Define the seat number of the ticket. Then in the parameter, you can say seat number. And that's, in this case, sufficient. If someone is using your class, they will have some idea that it is a Super Bowl ticket, because that's the name of the class, and that should be enough to get them going. If you write 27 lines of code here in your documentation, the Javadoc tool will only show people the first couple lines of it anyway. So keep it simple, keep it short. If you can't summarize what that property is in a couple of lines, then you probably didn't implement it correctly. All right, now we also promised to do some more validation, and the seat number setter is an excellent opportunity to do validation because we have intuitively a pretty good idea what a seat number should generally look like. First of all, it can't be negative, it probably can't be 0, and it probably is no bigger than some maximum value. Now the maximum value is going to be a guess depending on the row that it's in and the stadium and all that, but we can certainly make sure that someone doesn't give us a negative seat number. And that's very easy to do. We can just put some validation logic in here. If seat is greater than 0, store the new seat value. I can't type. And we could add a comment, validate the seat number before we store it. That's a little bit obvious right now, but I encourage you to put in comments even if they seem obvious. Something else you might want to do is add to the Javadoc must be greater than 0. How about that? That way when somebody reads your user documentation or programmer documentation, they will see that they can't pass in a negative seat number. All right, that's a good place to put validation. So if you're looking for rules to follow, you're looking for design or implementation guidelines, I guess. A good implementation guideline is that put data validation logic, when possible, into the setters of these private properties. This is an illustration of how object-oriented programming is supposed to work, where the knowledge of how a seat is modeled follows along with the code. We're not asking the people who use our class to understand everything about that class. So I'm not going to make other developers verify or validate their own data. I will do that, and it becomes part of that class. And that makes everybody's life easier. I'm the Super Bowl ticket expert, and the knowledge of a Super Bowl ticket is programmed into this class, and nobody else has to worry about it. That's the theoretical part of encapsulation. So when you're asked about encapsulation in a job interview, what you're talking about is how we can take code and data and put them together in a class, and they move together throughout the program. They never get separated. In the pre-object oriented days, we often had a problem knowing which methods we could call on which data. Since data and code weren't bound together into a class, we made mistakes by calling the wrong methods against the wrong data. But object-oriented programming allows you the opportunity to avoid doing that. Something else that you always need to put in a class is a toString method. Another design rule that we have. So when you create a class, after you've built your properties, after you've implemented your getters and setters, and you've added any other logic that's necessary, what you want to do is do public string toString, and it doesn't take any arguments. It never does, but it returns a string. And this is a standard Java method that everybody expects to see in the classes that they use. It needs to look just like this. And then in here, you're going to build something that represents a string representation of that object. What do you think other programmers are going to want to know about that object when they're debugging their code? Okay, this is not going to appear in production. No one should be using this to build a web page or a report. It should be used during the debugging process to get a quick representation of the object. What do people want to know? So what if we say seat, and how about equal sign plus seat? There's a start. This method now sends back or returns a string that contains a description of that object. The description isn't that great so far, but at least it's telling all the other developers what the seat number is for that object. And we look at that and we think there should probably be more here. So we will say plus, comma, row, whoops, row equals plus, comma, section equals section. It's a little bit better. If you gave that some more consideration, you'd probably say, I wonder if the GUID should be in there. I wonder if that needs to be part of this toString method. Remember, this is just arbitrary. Okay, you as the creator of this class are deciding what a useful string representation of the object is. And as objects get more and more complex, you will be leaving out a lot of things. You don't always put in every private property when you build that toString. A minimal descriptive set of data is fine. And I'll just put the GUID in there. Plus, quote, comma, plus, we'll just call it ID. How about that? That's helpful. Other programmers can use that when they're debugging. And then you can put in a little Javadoc, which is easy. Huh, that was interesting. Why didn't it put the string parameter in there? Let's try it again. That's still not doing it. Okay. Return a string representation of the object. We all know what the toString method is. Everybody knows what that means. Everybody expects it to be there. You don't have to say too much about it. Now, we have some semblance of a working model of a Super Bowl ticket. Let's go back to the main and let's do something with my ticket. Let's establish a row. Let's say row 1. And let's establish a seat and a section. My ticket dot set seat, I don't know, 42. My ticket dot set section 100. Good. We're still not generating any output. Let's call the toString. System.out.println myTicket.toString. Whoops, got a Y on the end of that. All right, we've exercised quite a few of the methods in our class. Does it generate output? There it goes. You can see the toString is a very useful tool. I don't have to think about formatting a string. I don't have to think about creating some useful output. All I have to do is call toString, and the knowledge of what a ticket looks like is built into the ticket class. It's not something I have to figure out and derive. Another feature that other developers might want from this class is a way to initialize an object when it is instantiated. What we have so far is what's called the default constructor. In the Super Bowl ticket class in line 16 in my code, we have a constructor that takes no arguments. That's called the default constructor. If you don't do anything, when you create a class, you get, by default, a constructor that takes no arguments, and we grabbed a hold of that and put a little bit of code into it to initialize that ID property. So that's the default constructor. It's possible that other developers might want to use it this way, and I'll just type this in and talk about it. Public Super Bowl ticket, open paren, and then they might want to send in a seat, a row, and a section as part of the instantiation process. Instead of having to hard code 3 more lines of code to call set seat, set row, and set section, they want to pass those into the constructor. Now we have 2 constructors, and this is going to be this. Actually, let's just call set seat. Seat, you can see the pattern building here. Set row, row, and set section, section. Oh, that one got out of hand. But we're not done yet, because look up at the default constructor and notice that it does a little extra. We need to put that same code down inside this other constructor. This gives developers the capability of creating a ticket with no seat and no row and no section by calling the default constructor, or creating a ticket with a predefined row, seat, and section by calling this other constructor. And this guy needs a Javadoc. So set up a Super Bowl ticket. Then you define these 3 things: the seat of the ticket, the seat number, I guess. And you could duplicate that. And this would be row, and this would be section. There you have another constructor. This technology is called overloading the constructor. Both of those methods have the same name. They're both called Super Bowl ticket, but they have different signatures because one of them takes 3 parameters. The first line of a method is called the signature, and you can see how line 20 has a different signature than line 16 by the parameters. They have the common method name, but they have different parameter lists. Let's go back to our main and illustrate the use of this new constructor. Let's call this my other ticket. Got to declare it, sorry. Super Bowl ticket, my other ticket, equals new Super Bowl ticket. And then in the parentheses of the instantiation, okay, you can see how it's the same syntax as line 10, but we're going to put those 3 arguments into that instantiation syntax. So we're going to say row 1, comma, seat 43, comma, section 100. This is right next to the other ticket. If I got them in the right order. I guess I could hover here and see seat row section. I got them backwards. this is 43. This is 2, right? No, this is 1, yeah. Okay. Now I have 2 tickets that are physically adjacent, and when I call the constructor, it will magically build that global unique identifier and store it in that new ticket. Pretty neat, huh? We can complete the thought by printing, whoops, the toString. This is going to be my other ticket. There we go. 2 tickets, seats 42 and 43, the same row, the same section, and different global unique identifiers. The next thing we'll do is create a copy constructor. This is another constructor with a special signature, and it's a feature of a class that you would usually provide. Most developers would like to see it. Sometimes it's not convenient or functionally useful to do. In this case, it's going to be on the border. You can decide. You'll see as we get through that this might not have been a good idea. But we'll do it just to illustrate the concept. And I'm going to jump back up to the top of this class just so I have a little bit extra space. And I'm going to create another constructor. It's going to look similar to what we've already seen. Public super bowl ticket. But in the signature, it's going to accept another, whoops, I didn't give it a name. It's going to accept an object of the same type. You need to be able to recognize that this is a copy constructor because of 2 features. One is it's a constructor. It has the same name as the class. That's easy. They're both called Super Bowl ticket. But the parameter list is another object of the exact same type. In this constructor, you can call to make a duplicate of what you already have. In some cases, in many applications, we need to copy something so we can edit it or send it to somebody else or store it in a different location. And in order to copy it, it's very convenient to have this copy constructor provided for us. This goes right back to that initial comment that I added to this class way an hour ago. How will other developers use our class? Well, chances are they may need a copy constructor. Therefore, you would have to give that careful consideration. What happens in here then? Well, all we're going to do is we're going to take the stuff in the parameter and we're going to use it to establish the values in our new object. And that means just usually, well, not usually, but it does mean in this case repeated calls to getters and setters. You have to be careful what you're getting and careful what you're setting. Once you see the pattern, it's easy to duplicate. And I did seat. I'll do row. And I'll do section. Okay. I'm not done because what about the GUI? What about the GUI? Can I do this with the GUI? Well, I can do a this dot set ID, right? It would be like that. Open paren ticket dot get ID. Can I do that? It's the same pattern as the other previous 3 lines for seat, row, and section. But there's a problem there because there is no set ID. Remember we took it out earlier? We decided that the ID field needed a getter but not a setter. We decided it didn't make sense for other developers to override or redefine that global ID once we established the value of it. Did we outsmart ourselves? If you scroll down, there's the get ID. There is no matching set ID. We broke up the set. What can we do? We've got a syntax error. There is no set ID method in this class. Well, what we can do, one solution to this, is we can write the set ID. And you're thinking, hey, didn't he just say that we shouldn't have one of those? Yeah, but what if we make it private so nobody else can use it by mistake? How about private void set ID, open close paren, it's, what is it, GUID, ID, and then this dot ID equals ID. Okay. Did I spell GUID wrong? Oh, it's UUID. I'm sorry. There we go. That's private. We can use it. We understand the ramifications of it, but we won't let anybody else outside the class use it because it's private. That makes our error go away up here. The constructor, the copy constructor, is now good to go. We can Javadoc it, copy constructor. Whoops. You don't need to say much here because everybody should know, developers should know, this is a copy constructor given that it's the same argument, the same parameter rather, as the name of the class where it lives. It looks just like every other copy constructor they've ever seen. And if you like, you can finish this thought here. The Super Bowl ticket object to be copied. Whoops. That's a little much. You don't have to do that, but you can. Let's finish the thought with the copy constructor. I will flip back over to the main class, and I will just make one more ticket. I will say Super Bowl ticket duplicate equals new Super Bowl ticket, open paren, and I will duplicate the my ticket that we created earlier. My ticket. Okay? That's all you need to do. You call the copy constructor by referencing the constructor name with appropriate parameter in that new syntax. So this makes a copy, makes a, let's see, makes a new ticket and copies into it the values from my ticket. Okay? And what's important for us now is the syntax of this and how it works, whether or not you should do this, and whether or not it makes sense to copy something is completely dependent on the context. In this case, I would say just at first glance, making a copy of a Super Bowl ticket inside my program might not be the best idea. But I haven't written a lot of code yet to use this class, and maybe there's a legitimate reason to provide a copy constructor, or maybe it shouldn't be in there at all. You just have to think about that. Look at your design documents, talk to your peers, get a really good understanding of the problem that you're solving, and then you can implement it correctly. I'd like to refer back to one of our slides from last time, and I made the point that you are modeling something when you create a class. If you don't understand what you're modeling, you better have somebody working with you that does. That may be a systems analyst, and you can't create a good model unless somebody has given you a good design, or you have created a good design based on your knowledge of the problem. And I've always spoken about throughout this presentation as well, know your audience. What will they be doing with your class, and what functionality will they need? And that's what you have to provide for them. The common good dictates that you aim for adequate. My class is adequate for the needs of the developers that will use my class. It does not go beyond that, because you would not know when to stop, my friend. You would be adding classes and copy constructors and overloaded constructors and properties and methods, and it would never stop. You have to find something that works for the immediate purpose. And as you get better at it, you'll understand generalities and how to make things more useful as you implement classes. But if your class is adequate for the intended purpose, if it meets the design spec, you are done. It's time to ship it. Now let's go back and look at the code some more. I am in Super Bowl ticket yet again. In the Super Bowl ticket class, I am going to add a protected method, and that's going to be, I don't know, protected reset ID. Okay. I am going to create the scenario. Let's just call it void. Sorry, I didn't give it a return type. Let's say that for the sake, and I still can't type void. There we go. For the sake of discussion then, that this class has gotten a lot of use, and you've realized that you need to give people a way to reset the identifier. There's been a lot of fraud, or the identifier wasn't quite right. It ended in an odd number, I don't know. But anyway, people need to reset that global identifier. But you want to be the gatekeeper for that. You want to make sure that they can't do that unless everything is all correct, unless all the stars are aligned and they're doing it the right way. But I know you know that eventually you're going to have to write this code. ID equals, and then UUID dot random ID. And I know I spelled it wrong, didn't I? Copy, paste. All right, I made that protected. Now, why did I make that protected? Protected is a little bit different from private and public in that inherited classes will be able to see this. Let me write that differently. Classes that inherit from this class will be able to see this. It will be visible to derived classes from Super Bowl. We might derive, we haven't gotten to inheritance yet, so we haven't spent any time on deriving classes. Perhaps there's a class of Super Bowl ticket that's a VIP level, and they can come in and they get free food, and they sit in a box, or they get to shake the player's hands or something. And that would be a special kind of ticket that might inherit or derive from this kind of ticket. And in that kind of ticket, there might be a circumstance where they would need to reset the global identifier on that ticket. Maybe it's a special kind of GUID for that ticket. So by making this protected, it will only be visible to other Super Bowl ticket classes that inherit from this. And I'll illustrate that if I go back to the main again and I just try to reference that method. I won't be able to. and I'll say my ticket equals, my ticket dot reset ID. Did I spell it right? R-E-S-E-T capital I. Now, if you look at this closely, you'll notice that I am able to reference that method in the main. And this is where things get a little confusing. So we said that because it's protected, that means that it cannot be visible, it cannot be used or recognized outside of this class and any other classes that inherit from this class. But Java is a little different that way, in that as long as this other class main is in the same package, it can also access protected members. And that's okay as long as you're comfortable with it. So let me show you the negative example where this won't work. Okay. And I'm going to have to create another package to do that. So I'm going to go new. Actually, watch, this is kind of easy really to do. I'm just going to change the package name to Super Bowl Ticket Main. And when I do that in the main class, main.java, Eclipse has a fit because physically main.java is not located in this new package that I specified. There is no Super Bowl ticket main package. So Eclipse has a fit. It puts up a red X and squiggles, and it says, hey, I can fix this for you. I can do one of two things. I can move main.java to the package that you just specified, or I can change it back to what it should be. So those are the two choices you have. Now, what if I pick the first choice? I'm going to say, okay, move this main.java from where it is now, from the package it's in now, to a brand new package, and Eclipse will automatically create that package for me. Watch the package or the project explorer, see what happens. Boom, new package, okay? And then inside that new package, there's my main. Now we're going to see a couple problems pop up, and we're going to circle back to that protected thing. The first problem is it no longer knows what a Super Bowl ticket is because they're not in the same package anymore. And that's easy to fix. Eclipse will add an import statement to the main, and it will bring in the contents of Super Bowl ticket.java from the other package. And that makes that error go away. See the import statement right here? But it's now in a different package, so the protected keyword comes into play, and that reset ID method is no longer visible to another class outside the package that does not inherit from Super Bowl ticket. Now this has to be, in my experience, learned over time. You need to see examples and experiment, but this is scope, and it's an important issue when we get more involved in inheritance. And we'll do more of it down the road, don't worry, but I told you we'd talk about it. Now we've seen public, private, and protected. Our primary concerns are public and private, but right there in the middle is protected, meaning that if you declare a method or a property protected, then it is only visible, that method, to objects that inherit from Super Bowl ticket or objects in the same package as Super Bowl ticket. Again, terminology, very important. I spew out these buzzwords, and it's really important that you can decipher what I'm saying so you can speak the language to other developers and you can solve problems together. We'll circle back to this again when we do more with inheritance later on. Let's do a couple more things together. First, I have to remove this reference to to reset ID because it's just not going to work. I'll add a comment here. This will not build because reset ID is out of scope, because main.java is in a different package than Super Bowl ticket. Okay, that has to go away. Now let's make a couple of errors and talk about them. So I want to do something with this. Let's make a new ticket. Super Bowl ticket, golden ticket, Willy Wonka ticket equals new Super Bowl ticket. And we're going to use the default constructor. Note that. Default constructor. What happens in the default constructor? Flip back over to the Super Bowl ticket class, take a peek in the default constructor. All we do is establish the global unique identifier. We don't establish a row, seat, and section. Those are still uninitialized, and they default to 0. We have a little bit of a problem now. If I print the toString, system.out, whoops, dot println golden ticket dot toString. I almost got it right. What am I going to get? All right, we already said a moment ago that row, seat, and section are not initialized. What is the toString going to do when it tries to print those out? Let's see. There it is, the last line of output in the console. You can see that I have no row, no seat, and no section. And that's possibly an opportunity for a lot of bugs to creep into the system, because you can create a Super Bowl ticket with no row, seat, and section. And if you forget to call the setters, then you're going to have that ticket in your system with no row, seat, and section, and you're going to have a lot of people show up at the stadium with a ticket, and they're all going to be looking for row 0, section 0, seat 0. And we would instantly realize that there's a programming problem, because nobody in the real world counts from 0, and there's no seat 0 in any stadium, but computer programmers count things from 0. All right, we've introduced then a possible way to make a lot of easy mistakes by providing this default constructor. Maybe this default constructor is a bad idea, because it lets you create a ticket without a row, seat, and section. Just a thought, okay? You as a developer have to keep those things in mind, that maybe you shouldn't let people do this. Just because they can doesn't mean they should. All right. And let's test our set seat golden ticket dot set seat. Hopefully this will fail. We added logic in the set seat method to validate the seat number, and we are refusing to store a number that's negative as a seat. But before we do that, let's put in a valid number. Let's see if it retains the valid number. Seat 300. That's a long row. I wouldn't want to sit in that row. And then let's do the toString again. What's happening here? The first thing we do is assign the seat 300 to our ticket. The second thing we do is try to assign the seat -1 to our ticket, and that should fail. That should not work. And then we print it out to see if it still has seat 300 in it. And if that's our desired behavior, then we're good to go. Review the set seat logic in the Super Bowl ticket class. The set seat logic is right there. It says if the seat is greater than 0 passed in as the parameter, it will store that value. Otherwise, it doesn't do anything. That means the seat will remain unchanged if it was an invalid attempt to redefine that seat number. Okay? Let's try that in our main. Whoops. Let's see what happens in our very last toString. Hopefully the seat number is 300. There it is. That did work. Good. We have made a simple attempt to validate the seat validation logic in the set seat method. Let's do one more thing. And we looked earlier in this presentation. There are, I've forgotten already, and I closed the tab. Oh boy. SoFi Stadium. Google has this pretty neat feature. They pop up on the right details of the stadium, the address, and all that. And they give you the capacity, 70,240 seats. There are 70,240 seats in SoFi Stadium. I need a bunch of my ticket objects. I'm going to sit here and type 70,240 variable declarations and initializations, and I'll be back in a minute. No, actually I won't. Just kidding. I am going to create an array list. Watch what I can do. This is really cool. Array list of Super Bowl ticket objects. Let's give it a name. Tickets, plural. And that's going to be equal new array list Super Bowl ticket. I spelled list wrong. And here's a place where I can begin accumulating 70,240 tickets. Notice that main.java doesn't know what an array list is, and it will offer to fix it for us by importing the Arraylist class. Okay, no problem. If you scroll back to the top, you can see that it added another import statement right there. Back to the bottom again. Let's do a for loop for int I equals 0, I less than 70,240, I plus plus. Let's create tickets. So ticket, tickets dot add, open paren, new, Super Bowl. Ticket, open close paren. There we go. I can run this loop and I can create 70,240 tickets. Think about that for a minute. There is a logic problem here. Do you know what it is? The logic problem is that, as I mentioned a moment ago, these tickets don't have row or seat or section numbers in them. But maybe this is what I need to get myself started, and I'll come back later and I'll add those using some other logic. And I don't know what the rows and seats and sections are in that stadium. I can't even begin to provide that functionality without studying the stadium in great detail. At least, though, I can demonstrate to you how to use an array list to accumulate a very large number of objects in a hurry. And let's see what happens. I like to put a print statement in here. System.out.println. Done. Because this could take a while. At least I get some kind of visual cue that I'm finished. But sometimes I also like to put something at the top of logic that might take a while. And I can say here, starting to initialize all tickets, ... Just my preference. That's just something that makes me happy. That way it prints out a little message, then it goes into that loop, which could take a little bit of time. Finally, when it's done, it prints out done. Let's see what happens. That didn't take that long. It was a little bit of a blip there. But I was able to create 70,240 tickets. Now this is a trivial amount of memory required by this. This is not something that you'd need a database for until you were finished and you wanted to store all of these to persistent storage somewhere. But creating them is no problem. That's not a lot of RAM that you're consuming. Okay, I hope this was helpful. Please leave questions in the FAQ. Thank you very much.